Alrighty, we've got two topics concerning mixtures today that we want to go over. The first is how we could make something dissolve faster. So let's say that you've got some iced tea and you're wanting to dissolve some sugar in it to make it a little bit sweeter. So how could you make your sugar dissolve faster in your iced tea? Well, the first thing you could do is that you could stir it up. And stirring is going to increase the rate at which your iced tea comes into contact with the sugar, and so it's going to increase the rate at which the sugar molecules can be broken apart, surrounded by water molecules, just like we talked about with salt. Okay, so stirring is going to make it dissolve faster. If your sugar happens to be in big chunks, which sometimes happens when it gets humid, you could always kind of smash the chunks up and decrease the particle size so that your sugar will dissolve more easily in your tea. Okay, so make your particle size much smaller so that it will dissolve faster. The other thing that you could do, and a lot of people don't want to do this with iced tea, but I like to drink hot tea, and so if you increase the temperature, then your sugar will dissolve faster as well. Now, what you may notice is that increasing the rate of dissolving may look an awful lot like the same characteristics that we saw back in chapter 7 for how to increase the reaction rate of a chemical reaction. And they are very much the same, because what you're doing is you're mixing things up, you're causing the particles to move faster, to come into contact with each other more often, to give them more spaces in which to react or in which to dissolve by increasing that surface area. Okay, so again, if this looks familiar, it should, because we've covered the same type of processes before when we talked about chemical reactions. Now, if you have a mixture, whether it's homogeneous or heterogeneous, you should be able to separate that mixture using some very simple physical processes. Whenever you separate a mixture, again, no matter which kind of mixture that you have, it's only going to require physical changes. You do not have to do any kind of chemical reaction to separate a mixture. Now, you may have to change the phase of something, but you're not going to have to run a chemical reaction to get that mixture separated. So let's talk about some ways that we could separate some mixtures. And again, you'll see some of these in your book. I'm going to try to elaborate on them a little bit. So one way to separate a mixture is by magnetism. If you use a magnet, you can pull anything that is magnetic apart from anything that is not. If you've ever seen videos of great big recycling places, and they a lot of times they may have their plastic and their metal cans and all sorts of stuff just all mixed together, and so a lot of times the first thing that happens is there's a big powerful magnet, and it will attract anything that's metal out of that mixture, and so they'll separate the mixture of everything that's to be recycled by pulling out everything that's magnetic. There are things called iron filings, just little bitty pieces of iron that sometimes get mixed in with things. You can use a magnet and pull those out of a mixture as long as what else is in there is not magnetic. Okay. The second type of technique that I can use to separate a mixture, one would be basically just kind of sifting something through, or by filtering something through. And it's going to depend on your particle size exactly what you're going to use. So if you're going to sift it through, you might use a sieve or a colander of some sort. And so this is going to be if you're going to have really big pieces of things that you want to separate. A really good example of this is if I'm going to make mashed potatoes, and I have chunks of potato in my boiling water, and I want to mash those potatoes. I take a big colander that's got holes in it. I set it in the sink. I take the whole pot full of water and potatoes and dump it into the colander so all the water runs out. and the potatoes stay in the colander. And then I can put the potatoes back into my pot and then use my sour cream and my milk and mash them up with my mixer. Okay, so that's one way to separate things, and that's going to be to separate something if you have big pieces. If you're draining pasta, you're separating a mixture by separating out the big pieces from the water. Okay, you could also filter something, something with more like a coffee filter. So if you have something, a type of mixture where you've got maybe some smaller particles, like maybe you've got sand and water, and you're going to try to filter the sand out of the water. You could pour it through a coffee filter. The water will run through the filter, and the sand will stay behind because the particles are too big to go through the coffee filter. Okay, so sifting or filtering will cause a mixture to be separated. Sometimes, though, you may have something like, especially like in a solution, a homogeneous solution, where it's not going to be so easy to separate it. What do you do if you have salt water and you want to separate the salt from the water? Now, most of the time we wouldn't want to do that, but in places who have water shortages or like out on the ocean, a lot of times people will take that ocean water and they want to separate the salt out of it. And so you can use a technique called evaporation. And sometimes this will include boiling as well. So if you took a sample of ocean water and you boiled it, or you just let it sit and you let the water evaporate off, what's going to be left behind? Well, you're going to have salt left behind. If you've ever gone swimming in the ocean, you see that happening, because if you swim in the ocean and then you get out of the ocean and you dry off, you see all that salt kind of is still stuck to your skin. It's because the water has evaporated off and it's left the salt behind. So you can use that same technique to retrieve something that has been dissolved in water. You could do it with sugar. You could do it with anything that's been dissolved in water. If you evaporate the water off, just allow the water to evaporate naturally, like it does off your skin when you're swimming, or you could boil the water off and expedite the process a little bit. Finally, the last process is going to be called distillation, and this isn't something that you and I are going to use in our everyday lives a whole lot, but this is going to be used among liquids that have different boiling points. Different boiling points. Okay, so if I have, say, isopropyl alcohol and water, we mentioned that as a homogeneous mixture. There is a type of apparatus that you can use, and I know I used this when I was in college for some of the lab exercises that we had to do. So you have a flask that kind of sits down here like this, and you put your liquid in here that you want to separate. And you're going to put a flame or a burner down here so that you can cause this liquid to boil. Now what happens then is that on top of this, you have another type of apparatus attached to it like this, and there's a really, really long tube that has another really, really like a tube inside of it as well. And then this is actually hooked to another flask down here on this end. I'm not an artist, so hopefully I can get across the point here. So what happens is that you start boiling this mixture, and say it's a mixture of alcohol and water. Alcohol is going to boil before water will. And so if you carefully control what temperature you have it at, then what you can do is you can only raise the temperature enough so that the alcohol will boil first and then the water gets left behind. So as the alcohol starts to boil, it starts going up here as a gas, and then it's going to go into here, and then you are able to run water through this tube without it touching it. It's like a tube inside of a tube, and so you kind of run water on the outside of this, and then it cools this gas down, and then this alcohol will drip into this container over here, and so then that allows me to separate my alcohol from my water, and it's based on the fact that they have different boiling points. So this is called distillation. So that's what that is. So 4 main techniques that we can use to separate mixtures. And the thing I really want you to remember here is that this does not require a chemical change. They're only physical changes. Separating something is only a physical change, and even if you have to evaporate it or boil it, remember all that does is it changes it from a liquid to a gas. It doesn't change the chemical makeup of what you're boiling, okay? So that is separating mixtures, and you're going to get some practice in a lab doing that very thing.